How to find exact values for 45-degree reference angles. So I'm going to start with the background. So imagine that we have a square. Sorry if this doesn't look too good. I guess that's not horrible. And so we know about a square that the angles are all 90 degrees and the side lengths are all the same. So let's say that I label the sides X. And now imagine that I draw one of the diagonals of the square. What I've done really is broken the square into two right triangles. So let's just focus on one of those right triangles, maybe this one here. And I'm going to redraw it over here. So this right triangle, because of drawing in the diagonal, we split those angles into 45 degrees. So we have a 45, 45, 90 right triangle. That's a special right triangle because it has a special side relationship. We know the legs are still length x and x. And if you use the Pythagorean Theorem, you can find out that the hypotenuse is length x square root 2. So an example of that would be if you had a 45, 45, 90 where the sides were length 7, the legs were 7 and 7, then the hypotenuse would be 7 square root 2. Well, the easiest way to think of it is just thinking about the proportion instead of x, x, and x square root 2. Think about it like this, 1, 1, and 1 square root 2. So every time you have a 45, 45, 90 triangle, the sides are always in the ratio 1, 1 square root 2. So that's what we're going to use to figure out the exact values for our 45-degree reference angles. Okay, imagine you need to find the sine of 45 or the cosine of 45 or some exact value of 45 without using a calculator, and you need an exact answer. So what you're going to do is draw a 45-degree angle on a coordinate system, put the angle in standard position, and then drop a perpendicular, and that gives you what we call a reference triangle. And whether or not your triangle looks like a 45, 45, 90, don't go by how it looks. We don't necessarily draw things accurately. But you have created a 45, 45, 90, so you can label the legs with 1 and 1 and label the hypotenuse with 2. Once you have all the sides labeled, you're ready to find any exact values you need. So the sine would be opposite over hypotenuse, so 1 over square root 2, which rationalizes. When you multiply the top and bottom by square root 2, you get square root 2 over 2. The cosine would be adjacent over hypotenuse. That's also 1 over square root 2, so it's also square root 2 over 2. The tangent would be opposite over adjacent, and that's 1 over 1, so that's 1. Cosecant would be hypotenuse over opposite. Square root 2 over 1 is square root 2. Secant would be hypotenuse over adjacent. Square root 2 over 1 again is square root 2. And cotangent would be adjacent over opposite. 1 over 1 is 1. So you end up with a lot of repeated values when you're doing a 45-degree reference angle because you have the triangle that has the same side length twice. Okay, suppose you're asked to find exact values for 135 degrees. So what you're going to do is draw the angle in standard position, 135. It's going to look about like that. And then you need to realize that what you have left between the terminal side and the x-axis is 45 degrees. So inside your reference triangle, you have a 45-degree angle. So once you know that, you can label the sides with 1 and square root 2. And because we went left, and that's the negative direction, you need to put a negative on your adjacent side. Once you have your sides labeled, you can just go through like we did on the last one. Sine is opposite over hypotenuse, 1 over square root 2. Rationalize it to square root 2 over 2. Cosine is adjacent over hypotenuse, negative 1 over square root 2, so that's going to be negative square root 2 over 2. Tangent is opposite over adjacent, so 1 over negative 1 is negative 1. Cosecant is hypotenuse over opposite, square root 2 over 1. Secant is hypotenuse over adjacent, square root 2 over negative 1 is negative square root 2. And cotangent is adjacent over opposite, negative 1 over 1 is negative 1. Okay, moving on to quadrant 3. Suppose that you're asked for an exact value for a 225-degree angle. So you're going to draw the angle in standard position, going counterclockwise, and you're going to end up right about there. So this entire angle is 225. But to find the exact values for 225, you're going to use your reference triangle, and hopefully you realize that you have a 45-degree angle in it because going around half a circle is 180. Add another 45 to that, you get 225. So once you realize that you have a 45, 45, 90 triangle, you can label the legs with 1 and 1 and the hypotenuse with square root 2. And because we went left, we need a negative on the adjacent, and because we went down, we need a negative on the opposite to indicate direction. Now that we have that, we can go through just like we did before. The sign is opposite over hypotenuse, negative 1 over square root 2. Rationalize, and you get negative square root 2 over 2. The cosine adjacent over hypotenuse, negative 1 over square root 2, rationalize, and it's also negative square root 2 over 2. Tangent opposite over adjacent, negative 1 over negative 1 is 1. Cosecant hypotenuse over opposite, 2 over negative 1, or square root 2 over negative 1 is negative square root 2. Secant hypotenuse over adjacent, square root 2 over negative 1 is negative square root 2 also. And cotangent adjacent over opposite, negative 1 over negative 1 is 1. And finally, if you need to find exact values for 315 degrees, then you're going to draw the angle in standard position. You're going to go all the way around 315 degrees, and that's going to leave you with 45 degrees. So once again, you have a 45, 45, 90 reference triangle, which you can label with 1, 1, and square root 2. Be sure to put a negative on your opposite to indicate the downward direction. And then all the same things again. Sine opposite over hypotenuse, negative 1 over square root 2 is negative square root 2 over 2. Cosine adjacent over hypotenuse, 1 over square root 2 is square root 2 over 2. Tangent opposite over adjacent, negative 1 over 1 is negative 1. Cosecant hypotenuse over opposite, square root 2 over negative 1 is negative square root 2. Secant hypotenuse over adjacent, square root 2 over 1 is square root 2. And cotangent adjacent over opposite, 1 over negative 1 is negative 1. So that's how you're going to find all of your exact values for your 45-degree reference angles. And chances are you'll just be asked to do one at a time, not all 6. So perhaps you're given the problem that says something like, find the cosine of 225. Okay, so you're going to say to yourself, where is 225? Let me draw this. If I start here, 225, that means I'm going to end over here. So you need to think about which quadrant you're ending in. And that gives me a 45-degree angle there. 1, 1, square root 2. Left is negative, down is negative. And then you're going to go ahead and calculate cosine, adjacent over hypotenuse, negative 1 over square root 2, and rationalize it. Another thing is that you can use this even if the angle is greater than 360. So let's see. I'm going to do a quick little calculation. Okay, so let's say you're asked to find the tangent of 495 degrees. 495? You got to be crazy. Well, think about what it's coterminal with. Subtract 360 from it, and you get 135. So 495 and 135 are coterminal, so they're going to use the exact same reference triangle. So the tangent of 495 is going to be the exact same thing as the tangent of 135. So picture drawing the 495-degree angle. What you would end up doing is going all the way around an entire circle, 360 degrees, plus an additional 135 degrees. So that takes you to the same place you would be if you just did 135, leaving you with 45 degrees and 1, 1, square root 2. Put your negative in place, and then you could calculate the tangent, and that would be negative 1. Okay, so that is how we find exact values for 45-degree reference triangles.